So the humanity can do that. Okay, this one is we will use as a US standard. So previously we do the air conditioning calculation based on the Australia, but this one is given in the fee. So we have to use a US standard. So in this case, this is a home is given. This home got as a 2 living room and a 4 bedroom and 1 bathroom. 2 living room, 4 bedroom and 1 bathroom and then 1 dining room, and also it includes a space. So the floor plan and so this one is the elevation plan all given. So we need to calculate the air conditioning heating load calculation for this room. So this is I already point out the north, east, south, and the west. So this top one is the north, this one is the east, this one west, and the bottom one is the south. So those are given. So in this case, I also given the windows. Windows are W is a window. All W windows got the 6 multiplied 7 feet. So this means that width is 6 feet and height is 7 feet. And W1 window, all the W1 windows got the 3 multiplied 3 feet. So those are the dimension of the window. So those and windows are sizes also given. So that this is a floor plan. You can see that the dimension of the wall. You can see the dimension of the part of the house, and also it's also given as a windows. The size of the windows are given. So those are given, and also there are 8 foot the outdoors ambient multiplier is 1/3. And summertime we need to maintain the inside temperature at 20 degrees centigrade. So 20 degrees centigrade is the same as 68 degrees Fahrenheit, and the outside temperature is 35 degrees centigrade or 95 degrees Fahrenheit. So this means the inside and outside temperature different with 95 minus 68, so 27 degrees Fahrenheit. So temperature difference cannot be. So outside is 95, inside is 68. So 27 degrees Fahrenheit. This is also given. So this is the summertime. Summertime typically is the outdoor temperature 35. Indoor is we want to keep at 20. So this is the 27 degrees Fahrenheit is the temperature different. And also given the windows. Windows are triple glass. So the type of the window is given triple glass. So based on the type of the window, we have to refer the appropriate table. Also the east wall are the timber. So east part of the wall is made of the timber. Timber means R11 gives the insulation, half inches gives them the both is installed at the east wall. And north, south, west wall are masonry wall. So they got the grade is R11. So this is the construction of the wall. East wall is made of the timber. So R11 gives these insulation, half inches gives them the whole, and north, south, west walls are masonry wall. So this is R11 insulation. And also the ceiling. Ceiling is plasterboard. So plasterboard is a 12 to 13 inches insulation. The size is R44. And also you see the W3 window. W3 windows are normally closed. So only the W and W1 windows will be opened. W3 windows are normally closed. And floor is made of the concrete slab. So this is the R9 insulation. So there are the 4 people living in this house. So this is the 4 living room and 4 people living. So because of this one, we need to calculate the rooms of heat emission. So the heat emission means the heat emitted by the people and also heat transferred from the outside into the house. So this is the 3 things that have to be calculated. So those things are given. So related to this one, you have to refer the appropriate table. So now I give you some of the table. So this table I will give you. So table data you have to refer to calculate the heating and the cooling load. So I give you the same table data. First table is cooling load. Cooling load means that normally the whole worksheet you can download from my site. But now I give you the extract from this worksheet. So in this case, this is the cooling load and door and window. So there will be the single glass, double glass, and a triple glass. So the north side wall, for that you use a triple glass. So temperature difference is at 15 degrees. There will be the coefficient 11, 20 degrees for the 12, 25 degrees coefficient is nothing. And east and west wall, so temperature difference is at 15 degrees coefficient 38, 20 degrees 39, and the 25 degrees 40. South wall is a temperature difference 15 is at 90, 20 is 20, and the 25 is 21. So those things are cooling loads are door and the window. So table given. Another given is a inflation multiplier. Inflation multiplier means the inflation is that when all doors are closed, the air stays coming into the house. So this inflation multiplier, air chamber hour, depending on the flow area. So that I also give you another table. This is the infiltration multiplier. This is the table P. Factor. So this is depending on the wall, masonry wall, ceiling, and flow. So I give you the data, some of the data from the wall, masonry wall, ceiling, and flow. So this is for the heat loss and gain factor. Okay, this is for the data for the heat loss and heat gain factor wall. So wall is a wood wall. In this case, half inches gypsum board. So cooling factor means that if the temperature difference is at 50 degrees centigrade, there will be 5, 20 will be the 6.4, 25 is a 7.8. For the masonry wall, temperature difference is 50 degrees centigrade, you have to take the factor 0.9, and for the 20 degrees, you have to take the 1.3, and 25 degrees difference, you have to take the 1.6. And another one is ceiling. Ceiling means that for the 12 inches to 13 inches insulation are 44. So when the temperature difference is 15 degrees centigrade, you have to take the factor 0.9, and 20 degrees, you have to take the 1, and the 25 degrees, you have to take the 1.1. And the follow the concrete slab, all the factor is 0. So those are the factor is given for the wall and ceiling and floors. So those factors are where to utilize. Which one? So firstly we have to see the living room. Living room 1. So living room 1 and the mirror. You have to calculate. So that what will be the total wall area? So total wall area means so this is a diagram I draw. One and the middle. So their area. So the living room 1 is 50 multiplied 30. So this is for the 30 into 10 plus 50 into 10. So this is for the 50 feet. This is how you see the top. Here, this is a 10 feet. This is elevation. Elevation is a 10 feet. The elevation, on the elevation you can see that the height of the house is a 10 feet. Like this, so this is for the height. So this is a 10 feet. So 10 feet. 10 feet means that we calculate the living room and the dining room. Living plus dining. Okay, we firstly calculate the living room plus dining room. So there will be the cross wall area. Cross wall area is wall is only here. This side, this is at 50 feet length, and this side is 30 feet. 50 feet and 30 feet. 50 is a length and the height is a 10. So 50 multiplied 10. This is for the living area. Okay? And another one will be this side. This side is a 30 multiplied 10. 30 multiplied 10. So then you can go the total cross wall area is 800 square feet. Cross wall area becomes 800 square feet. And also we can calculate the door and window area. Door plus window. So the door and window area that you see the window here. This is the view. This is the view. Two windows. So here you got a 3 window. One view here, another view here, another view here. So door and window area you can calculate. So there will be the 5 window. 5 window. So all the view windows got a side. All the view windows got a side is 6 multiplied 7. So there will be that you can see that door and window is 5 multiplied 6 multiplied 7. Then you got the 210 square feet. So then you can calculate the net wall. Net wall is that this is surface, so you have 590 square feet. So this is for that we can calculate the net wall area is 590 square feet. And also you need to calculate the ceiling. Ceiling area you can calculate the ceiling. So this area is a 50 multiplied 30. So this area 50 multiplied 30. Another one is 30 multiplied 30. Because we calculate for the door and window. Dining room and the living room. The living room area is this one. Dining room area is this one. So this one is a 50 multiplied 50, 50 multiplied 30, and this one is a 30 multiplied 30. And because of this one, the ceilings are total area will be this 30 multiplied 50 plus 30 multiplied 30. Then you got the 2400 square feet. See the area is 2400 square feet. And also we can also calculate the floors. Floor and the ceiling are the same, 30 multiplied 50 plus 30 multiplied 30. So then you got that 2400 square feet. So firstly we calculate the ground floor area, we calculate the door and window area, ceiling area and floor area we calculate. So firstly we calculate all the same. And then we have to calculate for the north window. So north window. So this is the north side. This one is the south. This is the east, and this is the west. So how many north windows? So this is the north windows are 2 windows. You see the 2 view, one view, another view. So there are 2 windows. 2 north windows. 2 north windows make 2 multiply. So you have to set as a factor. In this case, you have to see as a table B, table B. Okay, this is table B. So now window. What will be the temperature difference? Temperature difference, we firstly calculate the 27. So the highest one you have to utilize the 25. So appropriate temperature is here. The factor is 13 because we use a silver glass. Silver glass is given in the program that we given a thing. You can see that the windows are silver glass. Because the silver glass, this is a silver glass here. Temperature difference is 25. So reality is that for the 25 that should be 13. But in the program is 27. So more than the 25. More than 25, you have to utilize the factor 13. Because of this one, the factor is 13. Window, factor 13. So this is the north window. 2 window, factor 13. Multiply the side of the window. Side of the window is the view window. Those windows are the view window. So the view windows are already given. The view window is 6 multiplied 7 feet. So 6 multiplied 7 feet. So then you can calculate. So there will be the north window is 1092. So total feet transfer is 1092. And we also calculate the east window. So how many east window? Here you can see the east window is 2 windows. Because the W3, they are the only 2 windows is active. Because of the W3 windows are normally closed. The W3 windows are normally closed. So because of this one, although there are 3 windows, only 2 windows will be active. So because of this one, so the heat transfer is 2 multiplied. You have to set the factor. In the set factor here, east and west window. Here is and west window, feedback glass. So temperature 25 is at 40. So you have to set at 40. So this is at 40 you substitute. And the side of the window is 6 multiplied 7. So by solving this one, you got the thing is 3360. Okay, we got. So only that for the living and the dining room, we only need to concern the north window and east window. Because the south and the west does not have the window, so you don't need to do it. Only the north and the south we got the windows. So there's a 2 north window and 2 east window. So although there are 3 windows here, W3 is not active because the W3 is usually closed. So this is the only 2 windows so we calculate. So we got like this. And then this is for the window calculation. Now we will calculate for the wall. Okay, now wall will be the so there will be the firstly we calculate for the east wall. Wall also the east wall and north wall. So firstly we calculate the east wall. So east wall here. So east wall is the timber wall. So timber with a wooden wall. Half inch at gypsum board. So temperature difference 25 is a you have to set as 7.8. So the TBE for the wall. This wall is a timber wall. Timber wall, temperature difference is more than 25. So you have to set as 7.8. Because the wood frame, no insulation, half is a gypsum board. So this is 7.8. So that we substitute 7.8. And then we have to calculate the wall area. So wall area, what will be the wall area? Normally this is wall area is here. Each wall is at 50 and 10. 50 multiplied 10 is the wall area. 50 multiplied 10 minus, there are 3 windows. 3 windows, W1, W2, W3. So you subtract the 3 windows. 3 multiplied 6 multiplied 7. So by this way you got the base is at 374. So this is for the heat transfer from the east window. East wall is at 374. The wall area, total wall area minus 3 window area, we subtract, you got the 374. So W window and W3 windows are same size, but different one is the W3 windows are all the time closed. So there is no heat transfer, but to calculate the wall area, you need to subtract the window. So this is east wall is 374. And then heat also transfer from the ceiling. Heat transfer from the ceiling. So ceiling, to calculate the ceiling, you need to also calculate the total floor area. So living and dining room, living room 1 and dining room, total floor area is 2400. So floor and ceiling got the same area. So because of this one, you have to substitute as 2400. Multiply for the ceiling. For the ceiling is also given how the ceiling is constructed. Ceiling is a plaster board, 12 to 13 inches of insulation, R44. So then you see the table. 12 to 13 inches insulation, R44. Temperature difference is 25, 27, so more than 25, so that this data is at 1 by 1. So you multiply with 1 by 1. So 1 by 1, so we substitute here, so that will be the ceiling will be the 2640. And we also calculate for the floor. Floor means the total floor area. Total floor area is 2400. Table. Floor is you have to take the 0. So multiply 0. So this is 0. Okay, this is that we can calculate the thing. So those are heat transfer. 1092 plus 3360, 374, 2640. All that they have to add. Another one will be the inflation. This is for the total heat transfer. So this is heat transfer. No more. Yes. Also, we also need to calculate the normal. So here we can calculate is the north wall. So north wall area is there are 30 multiplied 10. So this is the 30 multiplied 10 minus. So there are two windows. Separate the two windows. So the 2 multiplied 6 multiplied 7. So the north wall you have to sell the factor. So you see that here. So the north wall. So this is for wall we have to utilize. So north wall is a masonry wall. Masonry wall. So this is an R11. So this is a 1/6. 25 is different. So you have to substitute a 1/6. So north wall is a substitute a 1/6. So by this way that you got a north wall. This way the 3, 4, 5 by 6. So this is the heat transfer through the window, ceiling and floor. Heat transfer. So this is a we calculate. Okay? This is a heat transfer through the wall. Ceiling, window. Heat transfer through the wall, ceiling and window, we calculate like this. And then we also have to calculate the infiltration. Transfer from the wall, ceiling and window. And then we also need to calculate the infiltration. So infiltration is, you have to use a formula. So it means the flow area multiplied and height, ceiling height, multiply 0.01833 multiply delta T multiply factor. So this is the infiltration. Infiltration is this formula. Flow area multiply, ceiling height multiply 0.01833 multiply temperature difference delta T multiply factor. So that you see here infiltration. So infiltration is closer to the area. This is amount for winter, another for summer. Now we have to calculate for the heating load. Cooling load means summer time. We want to calculate for the summer time. Summer time we have to take the average. Average flow area is over 2,100. Because we calculate the flow area, we got it at 2400. Because the 2400 is over 2,100, so the average is you have to take the 0.4. So this is the infiltration factor is you have to take the 0.4. And we substitute. So flow area you multiply. So flow area is 2400. Ceiling height is 10. So 0.01833. Temperature change is you have to separate the temperature change. Outside temperature is 95, inside is 68. So temperature change is 27. So you substitute the temperature change 27. So factor is 0.4. So by solving this one, so you got the P is 4751. So 4751, this is for the temperature. So to the heat transfer. And also we have to see that the P-pad. So P-pad also emit the heat. So normally the average heat, we have to use 300 BTU. So each P-pad, we use 300 BTU per P-pad. Because we are now using the US standard, so all the units are BTU units. Previously we saw the problem in the kilojoule. This is the Australian standard. Now I'm using this one in the US standard. So this is the units are the BTU unit. The reason is that most of of the air conditioning systems are designed by the US, so when you see that many reference book, data stay in the BDU unit. This is why I give you the both information. So because of this one, for the PPAs are emitted at heat. So each PPAs are emitted 300 BDU PPAs. They emit at 300 BDU. So there are 4 PPAs living in the home. 4 PPAs living in this house. So this is 4 multiplied 300. So that will be the 1200 BDU. Then we will add the all heat. Other heat you can add, so that we add the all heat. So 1092 plus 3360 plus 374 plus 345 plus 6 plus and 475 plus 1200 4751 plus 1200. So total heat you can calculate is 14962. 14962 BDU. So this is for the living and the dining room. Living room 1 and dining room, you calculate the heat, so the heat is at 14962 BDU. So this is for the living and dining room. And similarly, we calculate for the other room. So that will be that we can calculate the heat gain. So this is for the heat gain. And then we also have to calculate the living room 2, you can calculate. And living room 3, we can calculate. So after that, this one is a total heat. You also need to calculate the just gain factor. Just gain factor, we have to calculate. So this is for the just gain factor. Just gain factor. So just gain factor, we have to calculate. So just gain factor is equal to the formula 1/3 multiply the total BDU. Total BDU. So this is a 1/3 multiply 14962. You got there 19451 BDU. This is for the just gain factor. Gain factor for living room 1 and the dining room we calculate. Yes, 1/3 is a constant. So this is firstly we can calculate for the living room and the dining room. And another one we calculate for the living room 2. So I give you the living room 2, the formula. This is for the living room and dining room, and then I can calculate for the living room 2. So living room 2 is a cross wall area. Living room 2 is here. We calculate for this portion. 30 feet and height is at 10 feet. So that will be the cross wall is 30 multiplied 10. 30 multiplied 10. So this is at 300 square feet. And also door and window. So they are living room 2. We also put the 2 window here. So this is a window. Also that this one also got the So 2 door and window is all the things that we put as 2 window. So 2 window is we have to shelter the window area. So this is the door plus window. So living room 2 is a door and window area are the same side. So the door window area is this is 2 door windows. So 2 multiplied 6 multiplied 7. So this is 84. So this is we can calculate the net wall. Is equal to 300 minus 84. Is you got the 216 square feet. And ceiling. So ceiling means you see here living room 2. So this is 330 feet. And this is 30 feet. So this is 10, this is 30. And this one is 30. So 30 multiplied 30 is a CD is 900 square feet. So this is 30 multiplied 30. So 900 square feet. And floor. side also 900 square feet. And then we also have to calculate the south window and door, because living room 2, door windows belong to the south window. So because of this one, we have to calculate the south window and door. So south window and door. So that when you see the table here, the south window and door is here. So this is for the 25 degree difference, so you have to take the 21. So 21 multiply area. So there will be the 216, the area multiply 21. So by this way you got the 34556 BTU. So this is heat transfer. And then we also have to calculate the south window and door is the 21. So this is 2 windows. 6 multiplied 7 multiplied 21 is 1764 BTU. So heat transfer from the south window and door is 1764 BTU. And you also have to calculate the wall. Wall is also belong to the south side. So from the wall you have to calculate. So what kind of wall? The wall will be this is the masonry wall, because only the east side wall is the timber wall. Is a problem given. East wall is the timber, north, south, and the west wall are masonry wall. Because of this one, this is the south side is the masonry wall. So masonry wall is here 1/6 given. So the 25 is different. So 1/6. So the wall area multiplied 1/6. So wall area is 216. Multiply 1/6. Then you got the thing, it's a 34556 BTU. So this is the heat transfer from the wall is 34556. And then we calculate for the ceiling. So ceiling area is a total wall floor area is 900. Multiply the ceiling. So ceiling is, we also give it, ceiling is 1/1, so multiply to 1/1. So then you got it's a 990. Okay, floor. Floor is a 900 multiply 0 is 0. So we got the beam, so this floor area. And then we have to calculate the infiltration. So floor area is 900. Floor area is 900, so you see the table. Infiltration tables are 900 or less. Is you have to take them 0.5. So 0.5. So average, you have to take the average, the winter saturation, summer saturation. So 0.5. So then will be the floor area is 900. Ceiling height is 10. Multiply, the temperature difference is 27. Multiply 0.5 is a factor at 0.01833. So this formula you use. This formula is a area multiplied ceiling height multiplied 0.01833 multiplied temperature difference multiplied factor. So area is a 900, ceiling height is 10, temperature difference 27, and so 0.5 is a factor 0.01833. So by solving this one, this way you got the 2227. Okay, feedback. Feedback means we can assume that feedback can be more, but we assume that any row maximum feedback can be 4. Okay, this means that sometimes feedback they are in the 1 bedroom or the 1 living room, so that we move the feedback. So we have to take the every row we can accommodate up to 4 feedback. So because of this one, we have to set the all feedbacks are heat. So because of this one, for the south living room 2, we also put the 4 feedback. 4 feedback multiplied 300. Because we don't know who will visit in which area, so feedback can move. But in any place, maximum number of feedback in any particular place will be maximized 4. Because of this one, we have to set the feedback. So feedback is this is equal to 1200. Okay, we also assume that in this case, living room 2, we also put the appliance. Appliance appliances we also put. Those appliances are producing the 1200 BTU. Okay, so this is the 1200 BTU. So the appliance, we also put the appliance. So we just put the thing. So we assume, this is you can also omit, but now we assume that we got the some appliance in the living room two. So the appliance power produced by is 1200. So this is a feedback. So apply. It's a 1200. Okay, you add everything. So total heat will be 7726. So this is total. Total heat transfer is 7726. We got. And then we have to utilize the tap gain factor. So this is a 7726. Multiply 1.3. So all the thing you got is 10044 BTU. 7726. So total heat is 10044 BTU. This is for the living room 2. Living room 2 we calculate. And then we also calculate for the bedroom 1. Bedroom 2, so we use the thing. So bedroom 1 is belong to the bedroom 1 is this is beside the and south wall and the north wall. So this is we use a bedroom. So bedroom 1 we put the two window. So this is the bedroom 1 got the only one window here. Bedroom 1 also got the two windows. It's a two window here. Two window. And this one is one window. So we calculate for the bedroom 1. So bedroom 1 area. Area is a gross wall area is a 20 multiplied 10. So this is for the bedroom 1. So bedroom 1. So this is the cross wall is the south wall. So south wall area is 20 multiplied 10. So that will be 200. Window. So window is we can calculate for the south window. So this is a two window. 2 multiplied 6 multiplied 7. So this is 84. So you subtract, you got the 116. So this is the net wall. This is for the south. And we also got the west wall. So bedroom 1 also got the west wall. This is the west wall. So bedroom 1 is a total area we add the 10, 30, 10 and the 20 you add together. So this is 30 multiplied 10. So this is west wall is equal to 30 multiplied 10 is 300. So there are also two windows. One window here, another window here. So this is all the few windows. So 2 multiplied 6 multiplied 7. The windows are the window 2 multiplied 6 multiplied 7. So this is 84. So then we got the net wall. So net wall is this subtract, you got the 216. This is a masonry wall. Then we can calculate for the ceiling. So ceiling means to the area is this is a 20 multiplied 10. So this is the area is a 20 multiplied 10. 30 multiplied 20. 30 multiplied 20. So that will be the 600 square feet. Follow also 600. So that we can calculate for the heat. So south window. So south window area is we already calculate 84 multiply 21. So this is 1764. And south wall. So south wall is a 116 multiply 1.6. So 185.6. And west window. So west window is 84 multiply 40. So then we got the 3360. And west wall. So west wall is 216 multiply 1 by 6. So you got that 3, 4, 5 by 6. And ceiling. So ceiling area is at 600. Multiply 1 by 1. So this is 6 is 0. The floor is 0. Floor heat transfer is 0. So you add all the things. So we got that. So this is for the off heat and also the infiltration. So infiltration means for low end you 300 multiply, ceiling high is 10 multiply, 0.01833 multiply, 27 multiply 0.5. So then you got the thing is 1484. So this is it. And the P-band is so you can also add the P-band. But for the bedroom, the living room and the bedroom are different. Living room, 4 P-band can be. Bedroom is allocated for the particular P-band. So that because of this one, in this case, everybody is living in each bedroom. So that bedroom you have to calculate for the one. Yeah, only just one. So that bedroom is so bedroom is only one P-band. So this is 1 multiplied 300. So this is 300. Okay, so bedroom also we assume that we also got the appliance in the bedroom. The appliance in the bedroom is 1200. Appliance 1200. So you add all the things. So what you got is 8699. So then you have to calculate the infiltration. So infiltration means 8699 multiplied 1 by 3, you got that 11308. So after this is we already calculate for that living room 1, living room 2, bedroom 1. Okay, you copy fast, after that I set and then I have to revise. Okay, this is for us we can calculate for the door window. So that will be the bedroom 1 is 11308. Then we can calculate for the bedroom 2, 3 and bedroom 2, 3, bedroom everything we can add together. Bedroom 2 plus 3 plus bedroom plus WR, we can calculate. Okay, so because of that, bedroom 2, 3, 4 is north and west. So north side and west. Because of why we make the calculation is for the north side and west side, they are same masonry law, same walls and side. So this is west and the north. So everything we combine and we calculate. So then with the cross wall. So cross wall is what we will start. So firstly we calculate for the west. So cross wall is S. So the 10 plus 20 plus 20 plus 10. So there we will start. So the cross wall area is the 50. 10 plus 20 plus yeah, it's also 10. This is for the, you add the thing, so this is for 10 plus 20 plus 20, so this is for the 0 to 3. First one is 10 plus 20 plus 20, they will be the 50. 50 multiply, so this is the west wall. So 50 multiply, and then multiply with 10. We will just 500 and window. So windows will be the how many windows? So you see the table here. So this is the W1. So W1 window. This is the W window. So this is the W window. So this is the 3 window we got. So the 3 window. And we calculate barrel 2, 3, barrel and WC. So barrel 2, 3, and the barrel and the WC. WC means that here, this is the WC. This one is we call the WC. So there will be how many windows? So W1, W, so 3 windows. So that we calculate for the barrel 2, 3, barrel and the WC. So ground wall area is total 60. So total 60, so this is the 600. And the window, so this is the west window. West window is a 2 window. So 2W1 and 2W. So the 2W1 means that 2W is a 2 multiplied 6 multiplied 7. 2W1 is 2 multiplied 3 multiplied 3. So then you got the thing is a 96. So this is the net wall. Net wall will be the 504. And this is for the west wall, and also we can calculate for the north wall. North wall means ground. So ground wall area is you can calculate this is for the this is a 15 plus 5 because we don't use it, we don't calculate barrel, only barrel 2, 3 and barrel and WC so at this area. So 15 plus 5 is a 20. 15 plus 5 multiply 10. So this is 200 and this is window. So now window is only one window. So this is a one no window. One no window is only here we put the here. So only the one no window, so that will be the 1 multiply, this is multiply 7. So that will be the 42. So you subtract, so the 158. And ceiling. So ceiling area is 50 multiply 15 multiply 10 multiply 5. So 950. Because the whole area you can multiply. So this is ceiling height. And follow also 950. Okay, then we have to calculate the heat gauge. So firstly we calculate for the west masonry. So masonry wall is at 504 multiply 1 by 6. You got that 806.4. And this is north. Now also masonry. So this is 158 multiplied 1 by 6. You got that 252.8. And now window. So now window will be the 1 multiplied 6 multiplied 7 multiplied 13. You got that 546. And west window. So west window is at 96 multiplied 13. So this is 1248. And ceiling. So ceiling means that 950 multiplied 1 by 1, so 1045. And follow is 0. So you add all the things, and also you get the infiltration. So total floor area is 950, ceiling is 10, multiply 0 by 0, 1833, multiply 27, multiply 1. So that will be the 4617. So this is we call it infiltration. Barrel 2 and 3, so there are 2 people. And the appliance are the 2 multiplied 1200, so 2400. Then you add all the things, so this is a 13508 plus 600 plus 2400. So you got a 16505. Then this is the PDU, and you can calculate the charge gauge. So 16505 multiply 1.3. So multiply 1.3, you got the 21457 BTU. So you got like this. calculate this with a bedroom 4. So 15 multiplied 10. This is the gross wall is, this is the north wall. So this is 15 multiplied 10, so this is 150. Window is only one window. So window 6 multiplied 7, so you got 42. So then you subtract, so this is a net wall. Net wall is at 108. And ceiling. So ceiling is, you can calculate, ceiling height is at 10 multiplied 10. 15 multiplied 10, this is a ceiling. 150 floor. Floor also, this is a 150. So we have to calculate heat gain. So heat gain, we can calculate from the north window. So north window is 42 multiplied 13, so you got 546. And wall. Wall is at 108 multiplied 1 by 6, so 172.8. And ceiling. So ceiling means that 150 multiplied 1 by 1, so 165. And floor. Floor is 0. And also we also calculate for the infiltration. So all that floor area is 150 multiply 10 multiply 0.01833 multiply 27 multiply 0.5. Then you got a 371. So this is 1 people. 1 multiply 300, so you got a 300. Apply. So apply will be that 1200. 1200, so you add the 10, so this is 2754. And the other things are 2754. So we got, so this is for us that gain. So 2754 multiply 1 by 3. And you got that 3581.24. So we got the thing. So this is for the bedroom 4. Now we will calculate total. Total PJ, we have to calculate. So we add all the things. So firstly, we add the bedroom 1, bedroom 1. Bedroom 1, and we have to use a living room 1. So living room 1. Living room 1 is 19451. So living room 2. So living room 2, we calculate is 10044. And bedroom 1. So bedroom 1 we calculate is 10952. Bedroom 2, so bedroom 2 we calculate is bedroom 2 plus 3 plus 4 WC part and a WC. So this one is the thing is 21457 and the bedroom 4. So bedroom 4 you calculate is 3581. You can calculate total heat. Total heat gain, you add all the things. So all the things you add the things. So this is a 19451 plus 10044 plus 10952 plus 21457 plus 3581. So this is a 64585. So total gain is a 64585. So 64585 you got. So this is total heat gain. So now we change to the floor area. So then we can calculate the total floor area. So total floor area is living room 1. living 1 plus living 2 plus bedroom 1 plus bedroom 2 3 WC plus bedroom 4. So living room 1 is at 2400 plus 900 plus 600 900 plus 400 plus 950 plus 150. So then you got that total floor area. So this will be the 2400 plus 900 plus 400 plus 950 plus 150. So this is the 4800. Okay, this is for 4,800 square feet. Then we have to use that those videos plug within this area. So the BTU square feet second. So that will be the 64585 divided by 4800. So 64585 divided by 4800. So that will be 13.45. 13.45 we got. Okay, now you want to calculate the kilowatt. Kilowatt means BTU per square feet multiply 13.1.055. This is the formula. BTU per square feet multiply 1.055. You can change the kilowatt. This is the formula. So that this one multiplies the 1.05. So we work that you require the 14.1 kilowatt machine. This is 41 kilowatt air conditioner you require to cool those house. All the door window, everything TJ we calculate by formula and we add all of it. Then firstly we calculate the BTU per square feet. BTU per square feet, so all BTU divided by total area is 4800. Then you got the BTU per square feet. So approximately the kilowatt calculation, 1 kilowatt will do 1.05 BTU per square feet. So that those BTU per square feet multiplied with 1.05, you got the 14.1 kilowatt. So the machine requires the 14.1 kilowatt. So you need a 41 kilowatt air conditioner.